Hi everybody, and welcome to another of Mrs. John's lessons. This lesson is specially meant for year 12 physics, and it's for today, Friday the 14th of August. And this lesson is one more lesson on solving problems on Ohm's law, and we are looking at questions 4, 5 and 6 today. So I'm just going to explain how to do question 4, and I'll work through question 5 with you, and hopefully you should be able to tackle question 6. So that's our task for today. Okay, so these questions are in your booklet under Ohm's law, and it's on this page 19 in your booklets, and question 4 is on this page, but 5 and 6 are on the next page. Okay, so what I have drawn is the circuit given for question 4, and what we have to do is calculate the resistance of each of the parallel branches and then calculate the total circuit resistance. So in order to do that, we actually initially find the resistance of this branch, which is 1 over 4 plus 1 over 4 and then 1 over that. So you will get 2 ohms over here, and then you find the resistance of that in parallel. So first this in parallel, one number for this, so you're actually kind of replacing those two with a single resistor, and then you have the 3 ohm, and then you're replacing those two with a single resistor. Okay, and then you just add all these three, and that will give you the total resistance. So that's how you do the first part. And then the second part is calculate the circuit current. So once you've got the total resistance, you know the supply voltage, and the way that you get the circuit current is using Ohm's law. I is equal to V over R, where V is 12 volts and your R is the number that you just got by finding the total resistance. And then we have to find the voltage across the 3 ohm resistor. Now in order to do that, voltage is current times resistance, but we just have to make sure we are putting the same current. So what actually happens is, notice these are your junctions. Junctions are places where the current splits. So all the current drawn from the battery comes through this branch, and over here it splits. It's actually into two because they're both the same resistance, but over here it's all the current. So whatever answer you got for this, you've got to use that current times its resistance will give you the voltage across the 3 ohm resistor. Okay, so that's how you get that one. And then we have to find the voltage across the 4 ohm resistor. So what you need to do is only half the current flows through here. So whatever that half the current is, current times resistance will give the voltage across the 4 ohm resistor. Okay. And then the current in the 2 ohm resistors. So what happens is all this current splits into 2 equal halves because the resistances are the same. So it's just half the current going through each of those. Now then they have another part to the question. Another 3 ohm resistor is connected in parallel with the existing 3 ohm resistor. So I'm just going to draw that in blue. So here, this is your 3 ohm. This one's really hard to open. See if I can get that open. Okay, here we are. So you've got another 3 ohm resistor in parallel with the existing 3 ohm resistor. So that's a scenario. Explain what happens to the current drawn from the battery. Now let's just reason out here. When you add one more resistance in parallel, that resistance will be something less than 3 ohms. Okay, so when you add them all up, the total resistance of that is going to decrease. So if the total resistance decreases, then what's going to happen is the current drawn from the battery is going to increase. So that's your answer for that. And then explain what happens to the voltage across the existing 3 ohm resistor. So what's going to happen, there's going to be less current because the current here is going to split into 2. Okay, so then the voltage across that is going to decrease. So I hope all that made sense. So bye for now. and I will work through. I'll make another short video going through question 5 in your booklets.